Hey folks, so previously we did all this fun up here where we learned how to set up sine, cosine, tangent in order to find the sides of a triangle, but sometimes you know the sides and are looking for an angle. So when you are asking your calculator to find you the angle that has a certain sine, cosine, or tangent value, you have to use something that's called the inverse. And so it has this little -1 power that's basically invisible on this little notes page, but you'll see that it's the second function of each of yours. So if you do second and then hit sine, it's going to appear as sine inverse. Whoops. And what that's telling your calculator is you want to know what angle has a certain opposite over hypotenuse ratio, and then the answer it gives you will be the angle. So in this case, this is telling me that they know the tangent value, and it's asking what angle has a tangent that's equal to 1.3245. So that's the question you're asking your calculator. So you would hit second tangent, get out of the glare, sorry. So second tangent, and then you can see it appears with that -1 power. And then you give the decimal, which would have come from the fraction of the opposite over adjacent, because SOH CAH TOA is still where these tie back to. So in this case, the ratio of the opposite over adjacent is this 1.3245. And so you're asking the calculator, when would that be the case? And that would be the case at 52.9. So I would probably call that a 53-degree angle. So if you drew a 53-degree angle right here, the opposite over the adjacent would have a ratio of 1.3245. So here, because it's sine and I'm looking for a value there, I would do sine inverse of that value, and then, and it would tell me what angle would have that relationship between the opposite and the hypotenuse. So inverse sine 0.9761 tells me that's about a 77.4 degree angle. So angle A, because that's what they called it, must have a measure equal to 77.4 degrees. And you don't have to write this part. That's just me being fancy. All right. So, that's blank. Guess I didn't print back to back. Here we go. So now we're going to take a look at how do I use that in solving a triangle, because this is asking me to solve for the missing angle. Okay, well, I already know this one's 90, and this is the one in question. So just like yesterday, I'm going to label opposite, adjacent, hypotenuse. Then I'm going to use SOH CAH TOA. And from that, isn't it helpful when I take notes off the screen? There, I'm going to use that to choose one of those based on the given information, and then I'm going to go ahead and use inverse to solve. So I'm going to solve using inverse. So easy. Here we go. So from here, shoot across. That's going to make that guy the opposite. This one is across from the 90, makes that guy the hypotenuse. So I have opposite and hypotenuse involved. I'm going to use sine, but because I want the angle, I'll do sine inverse. I'll tell my calculator 40 over 42 is the relationship. So on that previous example, they had decimals. So what they had done is take the 40 divided by the 42, and instead of writing it as a fraction, they had given us the decimal value already. But either way, now I'm going to do second sine of that 40 over 42. And that's telling me that that angle, which isn't labeled, so I guess we'll just call it angle theta, is about a 72.2 degree angle. And because I'm doing an angle, I want to remember to write degrees. All right, so how about this thing? This would be straight across, making the 16 the opposite. This is next door, making it the adjacent. So that makes a tangent problem, but I'm looking for the angle. So tan inverse of my, pretend that's a 1, opposite over adjacent. So inverse tangent of my 16 over 30. So I know the two sides and I'm looking for the angle. And in this case, the angle comes out to be 28.1 degrees. Slick, huh? So you're going to be asked to solve the triangle, and that's going to mean finding all the sides and all the angles. So keep in mind that when you have uppercase letters, that is going to represent an angle. And when you have lowercase letters, that is going to represent a side. So I don't know what this blank is supposed to be. A blank uppercase, lowercase letter represents opposite side angle relationship. So I'm going to go with a matching. Let's do matching because that's what it's trying to tell you. Upper and lowercase represent an opposite side angle relationship. Okay, well, I'm a math teacher and that confuses me. So what that is telling you is if I have a triangle where this is angle A, across from that is going to be little a. If this is angle B, then across from that is going to be little side b. And then this would be angle C, and across from that is going to be little side C. So here, this verb, solve the triangle, means find all the missing sides and angles. Keep in mind those two geometry things we talked about on the previous video is that your angles need to total 180 degrees and that your sides are going to currently have the a squared plus b squared equals c squared relationship because it is a right triangle. So what I always do is if they give me the letters from the triangle, I write them out, capitals here, oops, and then I write the lowercase across from it. That just helps me stay organized. What was I given? What do I still need to find? That kind of thing. So in this case, they gave me that D is 90, so I write that in. They gave me that F is 49 degrees, so I write that in. And then they gave me that side F is 21. Now, I think about these things, not just trig. When I look at these, I know that these have to total 180. So I can take 180 minus the 90 and minus the 49. And so if you do that, you can use your calculator if you want to. You can have 180 minus 90, which is obviously 90, minus 49, which is going to give you 41. And so now you have your three angles. When you're doing these, it's usually helpful to draw a right triangle. And I don't even draw them to scale. I don't even try. Just draw a right angle. They told you that D is the 90-degree angle. So that's D, making the side across from it side D. Keeping in mind that that should be the longest side when I'm done because that's my hypotenuse, since this is the 90. Then E I'll put up here, which makes this side over here E, and then F will be across from little f. And I don't care if they're in proportion, I'm just kind of keeping track of stuff. So I've learned that this one is now 49. I've learned that this one's 41. Now I'm going to try to find the sides. And it doesn't really matter which one I find first. Let's say I decide to find side E. Okay, I like to stick with just picking one angle to work with. So let's say that I'm going to use angle 49 as my kind of starting point. That would make F the opposite, D the hypotenuse, and E the adjacent. If I'm trying to find E and the only one that I currently know is F, which is 21 because that was given, then the two sides that are involved are opposite and adjacent. So thinking back to SOH CAH TOA, opposite and adjacent means I should be using the tangent of my angle, which I chose 49, and that will equal the opposite over the adjacent. And because the E's in the bottom, these two will end up swapping out like they did on the previous video, and my E will end up equaling whatever 21 over tan 49 is. So if I do 21 divided by the tangent of 49, it turns out to be about 18.3. And now I could find this other side using trig, but I'm going to also keep in mind that Pythagorean theorem is a thing, And since I know the two legs, meaning the ones that come together at the 90, and I'm looking for the hypotenuse, I can take my 18.3 squared plus my 21 squared, and that will equal my d squared. So if I have, let's make that go away. If I've got my 18.3 squared plus 21 squared, and then I need to square root that whole thing, keeping in mind we learned that a half power is the same as square root, so you're going to see me doing that a lot because it's easier, just taking my answer to the 1/2 power, and that'll square root that for me. I got 27, I'd have to round that up to 27.9, and that makes me pretty happy because when I'm done, I like to check and say, okay, this is my hypotenuse, it should be the longest. And then over here, because 41 is slightly less than 49, I expect this number to be slightly less than that. So I'm pretty happy. Here's me being happy with the numbers I got and them being logical. Here, I don't have the luxury of a picture, so I'm going to go ahead and draw one knowing that it's going to be a right triangle, and then I'm just going to put the pieces on there as they describe them. I'm standing 15 feet away from a telephone pole. Okay, well, assuming the pole goes straight up, that's me over here. That's me, not drawn to scale, 15 feet away. With the end of a wire suspension cable connected to the top. Okay, so this is going to be the wire. If the angle of elevation, we talked about that previously, that means from the ground up, so that's this guy, is 49 degrees. How long is the cable? So this is the thing that I don't know. It's not asking me how tall the pole is or anything like that. And then I'm paying attention to this. Okay, so if this is the angle I know, then this is next to it. And this is the hypotenuse. I don't know anything about the opposite side. So with adjacent and hypotenuse, I'd be focusing on cosine. So the cosine of my angle equals the adjacent, which is the 15, over the hypotenuse, which is unknown. In this situation, I swap them out because the x is on the bottom. If you don't get why that is, think of it again like we did yesterday as this over 1 equals 15 over x. I'd cross multiply here, but then to get the x alone, I'd end up having to divide by the cosine 49. So I'm just kind of doing a shortcut and just knowing that when the x is on the bottom, these two flip-flop. So x will be 15 over the cosine of 49. So 15 divided by, oops, I got to clear out my other stuff. 15 divided by the cosine of 49, 22.9-ish. I can live with that. And what am I doing? I am measuring in feet, and I'm pretty happy because it's longer than this distance, and so I feel like that's a logical answer. Alrighty. Let's see. Of course there's nothing there. Let's see if there's anything else. That, my friends, brings us to the end of 13-point-nothing. So now we know everything. We know how to find angles. We know how to find sides. We know how to solve for the triangle. So I feel like you're experts. If you try the homework problems, there's worksheets online. There are answer keys online. If you're doing IXL or whatever the assignment is for this, you can still use the worksheets and the answer keys to help you look at a few examples if you need help. Otherwise, you can email me or jump into the Zoom room and get your questions answered. Take care. Peace out.